Graphing exponential functions when the base is e is very similar to when it's just a normal whole number or a fraction. I'm going to start with my asymptote. It's at y equals 0. And then I'm going to plug x as 1. I'm sorry, as 0. So I get e to the 0, which is 1. So my intercept is right here. This is the y-intercept at 1. And because the exponent's negative, it makes it a decay function. So it's always decreasing. My domain is all real numbers, and my range is y is greater than 0. Now for B, my asymptote is at 2. That's the line y equals 2. Solving for my y-intercept takes a little bit more work for this one, because we're going to get e to the negative 1 plus 2. Well, this moves, the negative exponent moves the e to the denominator. So 3 over e plus 2 is my y-intercept. E is 2.7. So this is around a little bit more than 3. So graphing it, and it's an increasing function. I can actually find, if I plug in 1 for x, that makes this 0, e to the 0, which is 1, so 3 plus 2 is 5. So I can get a nice point here so that my graph is increasing. And the domain is all real numbers, and the range is y is greater than 2. Okay, we can use our calculator for number 22. "5 p.m. is 5 hours after noon, so we're going to plug 5 in for t. So b equals 15,000 e to the 0.3 times 5. And to the nearest whole number is 67,225 bacteria. 120,000. So that is B. We can use our calculator to solve this, or we could solve it by hand. I'm going to divide both sides by 15,000. We get 8. So from here, from the beginning, I could have used my calculator in the graph to solve it, or I can use this in my graph to solve it. So I'll show you both ways. If I put this in y1 and this in y2, I can find where they intersect. And I find putting the 8 equals e to the 0.3t in easier than the humongous numbers at 120,000, so I don't have to play with my window as much, but both would work. So I'm going to set my window. Time can't be negative, which is our x, so I'm going to look from 0. Oh, well, actually, in this case, it could, because noon is in the middle of the day. It's not midnight. It's actually bacteria that can't be negative. Excuse me. So I will do a normal window now from 10 to 10. So I don't have to put all those numbers individually. So I'm going to do zoom 6. So there's my 8. Here's my e to the 0.3t. So I'm going to do second, calculate, find where they intersect, which is number 5. Arrow over to that spot. And hit enter 3 times. And we want 3 decimal places, so that is t equals 6.931. And that is hours. Now, I could have also solved that algebraically. So if we go back to this part, I can change this to to logarithmic form. Divide by 0.3. And from our main menu, we do the ln of 8 divided by 0.3. We get the same answer. So you can pick whatever way you like best to solve that. And for 23, years from today, the population is expected to be 7,000. We have to solve for the r. So 7,000 equals 2,000 e to the r, 10r. So r times 10 is 10r. We're going to divide by 2,000. And then solving this, I'll do this one algebraically. I'm going to change it to log form. Divide by 10. So that's the ln of 7 divided by 2 divided by 10. So r equals 0.125. That's 3 decimal places. Or I can convert that to 12.5%.